Okay, let's discuss transformations. Transformation questions are almost always given in the same format. It'll say if some function, normally it's an absolute value function, is transformed to a g of x, and then it gives some blurb. How did it move is the question. How did it move? And then you have to pick the correct answer choice that says, oh, it moved to the right this many points, it moved down this many points, blah, blah, blah. This g of x portion right here is always in the same format. So that's what we're going to talk about here. When I'm talking about A, C, and D, I'm talking about locations in that equation where you can look to figure out how the function moved. It's always in this format right here, where there's an A and then some type of F. This F represents the function that we're talking about, normally the absolute value, X minus C plus D. As you can imagine, there could be a B that's skipped. B normally goes here, but it's never tested, and honestly, it gets pretty confusing, and there's nothing that you can accomplish with B that you can't accomplish with A. So it's kind of, it's not useless term, but it's not a necessary term in order to move your graph around. So we like to focus just on A, C, and D. So the first place you're going to look is at A. This is the number right in front of the F. If you see A and it is a fraction, like 1/2 or 1/3, your graph is going to compress. That would be a vertical compression. Vertical compression. If you see that A is some type of whole number, like 2, 5, 10, 1062, doesn't matter what whole number, it is going to be a vertical stretch. And no matter whether it's a fraction or a whole number, if you see that A is negative, it will also be a vertical reflection. Okay, now let's talk about what these look like. Vertical compression, if I start with a graph, let's do an absolute value graph. If I start with an absolute value graph like this, a vertical compression is basically pushing this graph together. It's compressing it together. And so you're going to get a new graph that looks fatter like this. You've pushed it together, you've pushed it and compressed it, and now you have a fatter graph. A vertical stretch, let's say you have a graph that looks like this. If it's going to be a vertical stretch, you're going to take the graph and pull on it up and down. If you take a graph and pull on it up and down, it's going to be skinnier. It's going to stretch. So now your graph is skinnier. And if you have a vertical reflection, let's say you have a graph that looks like this, a reflection is going to flip your graph upside down. So now you have an upside down graph. Okay, let's talk about how C can affect the function. C, you're going to look right here behind the X inside the function. If you'll notice, there's a negative sign in there. What that negative sign does is it makes everything the opposite of what makes sense in your function. Okay, so if you see a positive C, like an x plus c inside that parentheses, if you see x plus c, that function is going to shift to the left, whatever this number is. So if you see an x plus 2, it would shift left 2. If you see an x plus 5, it would shift left 5. Whatever it shifts left, it's going to shift left by that number, whatever the c is. If you see an x minus c, it's going to shift to the right, whatever that number is. That's kind of the opposite of what makes sense because, logically you would think the negative would shift left. But again, that minus sign in the original equation right here makes things the opposite of what makes sense. Okay, last but not least, let's talk about D. If I have a number here that's after the parentheses, right? After the parentheses. D, if you see a plus, you see a plus D, that is going to shift up. And if you see a minus D, that is going to shift down. So now that we've exited our function, we're outside the function, we no longer have to deal with that pesky minus sign. Now things can make sense again. So logically, it would make sense that a positive thing would go up and a negative thing would go down. And sure enough, it does. So let's look at some example questions, if it'll let me go to the next slide. Okay, so let's look at some example problems. Here you can see that if f of x equals our absolute value of x, that tells you your function is an absolute value, is changed to g of x. Here is that form we were looking for that tells us how the graph moves. How is the graph of the function transformed? So the first place you're going to look is out in front of that f at this 5. This 5, since it's a whole number, tells you that the graph has a vertical stretch of 5. Okay, once we've done our A, now we're going to look at our C. This C has a positive 2, and so everything inside the parentheses is opposite, and it's going to be a horizontal shift left 2. Last but not least, we're going to look here after our function. Remember, this is now no longer inside the function, so things are allowed to make sense again. And we're going to have a vertical shift up 1. Okay, the same process applies even if we have a negative number out in front. So let's look at this problem right here. First thing I'm going to do is look at my A. My A, first and foremost, has a whole number, 2, and so I know that it's going to be a vertical stretch of 2. But I also notice that this A is negative, and that negative, if you'll remember, means it's going to be a vertical reflection. So this A actually makes it do 2 things, a stretch of 2 and a reflection around the x-axis. Okay, then we're going to look at this term right here, and you can see it is a -7, and so that tells you that it's going to shift to the right 7. Last but not least, our last term, or our last number out here is our D term, and that tells you it's going to be a vertical shift down 5. Vertical shift down 5. So this actually did 4 transformations on number 3. Last but not least, I'm going to do this problem. Our A is negative, and that negative tells you that it has to be a vertical reflection. This 1/3 tells you, because it's a fraction, that it's going to be a vertical compression of 1/3. Since I have a -4 right here for my C, that tells me that it's going to be a shift in the right direction because everything is opposite of what makes sense when you're in those parentheses. So it's going to shift right 4, and this 8 here tells me that it is going to shift up 8.